coffee pot, microwave, refrigerator, Siamese cat, bicycle built for two.
Okay, so I've been playing around a lot with TensorFlow lately, and I still know nothing about machine learning. So since I'm not qualified to do a full tutorial on this, today we're going to talk about why you might want to use machine learning in your augmented reality apps, and how to get it working in Unity at a high level. Also, I put the apps from the intro up on my GitHub page, so we'll go over how to set those up and use them later. Anyway, this all started for me last semester at the University of Pittsburgh. I agreed to do an independent study on sterile compounding. My professor's like, okay, the first thing we need to do is detect objects. I'm like, okay, cool. What are the objects? He's like, well, we don't know. We want to detect all kinds of objects. Okay, so you want me to detect objects, but you don't know what they are. Yeah. Okay. Ultimately, this is what I ended up with. They wanted an overhead webcam tracking the work area that could tell if two medical objects were blocking airflow to one another. If they were, the setup was supposed to send an alert to the user that was wearing a heads-up display and warn them to move the objects. The heads-up display is just a Google Cardboard style app made in Unity running on my iPhone 6s, and the overhead camera is running TensorFlow in Python, which sends the alerts via sockets to the iPhone app. Now, there exist pre-trained machine learning models for detecting objects that work really well. These models are designed to track classes of objects and not just one particular object like I am used to. This particular MobileNets model that you see here can detect up to 90 different classes of objects. So in this case, my project required me to train my own model for detecting medical objects. I had to take 150 pictures of each object I wanted to track, which in my case was medical bottles and syringes. Then I had to annotate each image to generate an XML file of the bounds of each object in the images. I then trained that model against the existing MobileNets model using transfer learning with the Google Cloud platform. Once I did this and it was working really well, I couldn't help but think of all the applications in the context of augmented reality. From what I understand, there's 3 levels of image processing that machine learning is used for. So there is image classification, where you can tell generically what is in the image. There is object detection, where you can draw a bounding box around the image. And there is image masking, where you can actually get an exact outline of the objects in an image. Now this lit me on fire because if we could get image masking working on mobile with an existing AR SDK that does ground plane detection, maybe we could infer the position of the object in 3D space for object occlusion or adding colliders for physics interactions. So in the case of image masking or object detection, we know spatial information about the detections in 2D space only. But if we know the angle of the ground with respect to the mobile device, we could cast a ray through the object, and where it hits the ground, we could attempt to estimate its distance from the camera. So obviously, I became pretty interested in getting this to work on mobile phones. Now, there are cloud-based solutions for IBM Watson, Google, etc. that have vision APIs for doing this type of image processing, but number 1, they cost money to use, so for me, that's not very scalable. And number 2, you're also hitting the cloud with every request, so for real-time processing, this does not work. The processing needs to be done on the phone. Now, there are native solutions for running ML models on Android and iOS, but I hate doing videos on stuff that's not cross-platform because I want everyone to follow along. Not to mention, I know nothing about making native apps. So naturally, I started looking for a solution in Unity. Ideally, I wanted something like Vuforia that abstracts the use of ARKit and ARCore, allowing you to cross-compile for both Android and iOS from a single codebase. There exists a TensorFlow Sharp plugin that Unity's ML agents runs on, so I thought I had found a solution. I spent a bunch of time getting object detection working in Unity and built it out for my iPhone, and it didn't work. I was pretty upset. It ended up working on my Android phone, although the detection was quite slow despite all of my multi-threading efforts. It turns out the TensorFlow library gets slimmed down on iOS, and it's missing some operations to run the object detection. I ended up asking some questions on GitHub, and it looks like it's possible to rebuild the TensorFlow core.a library from source in order to add the missing operations, but that type of thing is not really in my wheelhouse. Not to mention, I'd already lost motivation because performance was so poor on my Android phone. So I might try to revisit this sometime in the future, but for now, I'm just going to leave it alone. Anyway, I did get image classification working on both iOS and Android, and that works really well. So let's go over how to get that working at a high level. First, you need the TensorFlow Sharp plugin from here. Once you download that, you can simply drag it into your assets folder. In the player settings, add enable_TensorFlow to your scripting defined symbols and change the scripting runtime version to .NET 4.x equivalent. So TensorFlow pre-trained models usually come in the form of a frozen graph.pb file. TensorFlow Sharp in Unity needs to read them as a bytes file, so you can normally find a frozen graph and just change its extension from .pb to .bytes, and then load that graph in Unity as a text asset. So you may get an error loading the graph because sometimes TensorFlow models need to be served in the same version of TensorFlow that they were saved or frozen. If that is the case, TensorFlow Sharp runs on TensorFlow version 1.4 as of right now. So you may need to download TensorFlow version 1.4 on your computer and then reload and then refreeze the graph in Python for that version, which will create a usable bytes file that we can then pull into Unity. So if you download my image classification example from my GitHub, we can open it up in Unity, drag in the TensorFlow Sharp plugin, and if you look to the resources folder, you can see the bytes file of a frozen inception model. This is trained on the ImageNet's dataset, which has 1,000 different classes. All the class labels are in the ImageNet text file. There's also an ImageNet sounds folder. Every time an image is classified, I wanted the app to also speak the word. So OS X has built-in text-to-speech.
TensorFlow.
So I was able to write a little Apple script that opened up the ImageNet text file and converted each line to speech and then saved that audio file in another folder. So now we have 1,000 audio files that match the names of each label in the ImageNet's label text file. If we go to the scripts folder, the classification script is where all the magic happens. Like I said, I know nothing about TensorFlow or machine learning in general, so most of this was just adapted from the TensorFlow Sharp examples GitHub repo. So if you need any other help running these types of models, I would look there first. At a high level, this script loads the label file and reads it into a list of strings. Every time the screen is clicked, process image gets called, which creates a tensor from an image. That input tensor gets fed to the model, which gives us an output tensor containing all the probabilities of each label appearing in the image. Before we can feed that image into the model, though, it must go through some very specific processing. The image must get scaled and cropped, which is what our texture tools script is for. The TensorFlow Sharp examples also use a decode JPEG function that transforms the image before it gets sent to the model. Unfortunately, that op is not available on iOS, so if you built out with that, you'd get a bunch of errors. Luckily, Andrei Ashikman posted a GitHub project that gets around this functionality, so I was able to use his transform input function for a cross-platform solution. As far as the other scripts, message behavior just handles the movement of that little drop-down box for the message, and camera feed behavior just gets the pixels of the camera feed from Vuforia. Now, I use Vuforia because if you've ever worked with webcam textures before in Unity, you know that it's kind of a problem getting it to work on all the different devices. So Vuforia has already solved this problem. Also, I thought maybe you could combine ML and Vuforia in an interesting way, like having a character walk on the ground and then that character is what is speaking the objects that are in the images. Or you could do something like an AR scavenger hunt where you have to go seek out particular objects, something like that. I don't really know. Anyway, if you want this working on your device, just go to File, Build Settings, and switch your platform to Android or iOS, and make sure this scene is added to the build. For Android, you don't need to do anything too special, just make sure you put something in for your bundle identifier and uncheck Android TV. Build out the APK and use Android Studio or ADB in Terminal to put it on your phone. If you're on iOS, there's a few more things that we need to do. First of all, set your bundle identifier. Next, Vuforia has all kinds of problems with newer versions of Xcode and iOS. To prevent the camera initialization issues, make sure that you have the latest version of Vuforia, Unity, and Xcode before continuing. Even if you download the latest version of Unity, which has Vuforia packaged with it, Vuforia will still need to be updated. So click on the AR camera in the scene, and if there is a message to update Vuforia on the Vuforia behavior script, do that now before you continue. Once that new version is installed, you can hit build and open up the project in Xcode. So make sure to first choose your team. If you don't have a team, just create a free Apple developer account to get one. Now go to Embedded Binaries and remove the lib TensorFlow-core.a framework. Add the accelerate.framework. Go to Build Settings and click on Other Linker Flags. Add -force_load. Off to the right, find the ML Agents folder, click on Plugins and iOS. Now open back up Other Linker Flags and drag lib TensorFlow-core.a underneath force load. Now you can plug in your phone and hit play. Now, the object detection project is also on my GitHub if you want to play with that. You can just download that and open it up in Unity. Drag the OpenCV Sharp plugin and hit play. You should be able to just build out to Android and everything should work. This project does not use Vuforia because I was trying different techniques for optimization and I wanted to eliminate Vuforia. So if you're having issues with your camera feed, you may want to integrate Vuforia or some other plugin that will get a good camera feed. Again, unfortunately, it does not work on iOS, but if somebody wanted to recompile that library from source, that would be incredible because I'd love to play with it. Either way, that's all I got for today, so let me know in the comments what you guys want to see in the next video. Lee, are you peeing in the shower?
I'm sorry, dude. No. I literally peed in the shower because I thought I was making less noise.
All right, goodbye.
I'm sorry, dude.
Okay, just go.
I was doing that.
Just go. Give me 5 minutes.
Right,
Goodbye.
I'm sorry. I literally did that because
Go. It's fine. That was... Goodbye.